SlicerROS2, or how to leverage ROS within Slicer. All the code is on GitHub and the documentation on ReadTheDoc. SlicerROS2 is now a true ROS2 package, so you can use ROS-Run, ROS-Launch to launch all kinds of utilities, including Slicer itself. The core module is written in C++, but all features are accessible through Python bindings. There are widgets to display the state of subscribers, publishers, TF2, listeners, and broadcasters. To demonstrate the robot visualization, we provide a launch script that allows you to start everything you need on the ROS side for the UR robot. SlicerROS2 just needs the topic for the robot description. From there, it will load the RD file, parse everything, load the meshes, and create all the mermal objects corresponding to the robot. To manipulate the robot in SlicerROS2, you can use the new module Motion Control. You can control any robot with or without Move It configuration. You can control the end effector's Cartesian position using a 3D widget. The robot's color indicates if the state is valid or not. You can also define your target using the joint space. The 3D widget also allows you to control the end effector in the end effector coordinate system. Once your goal is set, to plan the trajectory, you can use either a simple built-in joint trajectory generator, Move It, or your own trajectory generator. The computed trajectory of the end effector can then be visualized in 3D. You can also preview the full robot motion or scrub through time to any desired position. SlicerROS2 comes with concrete examples. Each example is scripted, so anyone can reproduce them. The first example is a point cloud generated in ROS2 and then visualized in Slicer. One can also publish a point cloud from Slicer. In this case, we're using a sphere with a collection of points wrapped around, and then make the sphere turn around itself. In RViz, you can subscribe to the publisher for the point cloud, set a few parameters, adjust the size, and then you can see both. As mentioned earlier, all the SlicerROS2 features are accessible through a Python interface. So it is possible to load a robot, configure it for Move It, and then use a mermal object and add it to the Move It scene as an obstacle. Then the script can also bring up the GUI so the user can start immediately working with the robot and the obstacle in place. The user can drag the robot by its end effector, visualize in real time every collision and position based on what Move It can and cannot achieve. Once the final position is set, you can plan, preview, and execute as we did before. The last example provided demonstrates how to use 3D pose markers defined in Slicer for your trajectory. The trajectory will pass through all different pose markers. Everything can be done in script, and once the user loads the application, all you have to do is preview, execute. One major drawback of SlicerROS2 is that it needs Slicer to be compiled from source. This is so we can have binaries compatible with ROS2, which is installed on Ubuntu 24.04. The issue then is you cannot use the pre-built extensions provided by the Slicer community. To address this, we provide an extension manager. The extension manager loads the list of extensions from the Slicer website and allows the user, for each of them, to download the source code and compile it. The ROS2 script we use to start Slicer knows about all these extensions and their path, so they can be found easily in Slicer.